topic for right now is going to be operations with rational numbers. More importantly, we're going to focus on rational numbers that can be positive and also negative. You might have studied rational numbers, fractions and decimals and things before, but everything was nice and positive. Now we're going to get very, very much realistic. Actually, the next sound you hear is going to be the lid blowing off of all these problems that are now really going to be much more realistic, because not too much usually comes out to be nice twos and threes. You like to get into some negatives and also even to those fractions and decimals. One thing to remember, rational has the word ratio. That means that you can express anything that can be expressed as a fraction is technically a rational number. That could come in a form of common fractions, like -4/7, or even like 5, because you can put it as 5/1. Or it can also come in the form of decimals that stop, or decimals that repeat, because decimals that stop, like -75/100, can be turned into -3/4. Again, those repeating decimals, as long as it repeats, you got a chance you can put it into a fraction. In this case, the repeating threes we know better as a third. Again, they can be positive or negative now. We're going to be hopefully able to handle the numbers either way. Let's talk about addition. Addition, you have to be a little more on your toes, because you have to worry about, if you're dealing with fractions, you have to make sure that they have a common denominator. These first two examples I pulled out have a common denominator, so they're a little, ease us into it a little bit more. The fact of having a -1/8 and a +5/8. You can almost cover that up. Hey, -1 and a +5. That would be a 4. Now that they're denominators, don't let that mess you up. It'll be 4/8 now. The last burning question with all of your fractions, reduce. Keep that in your head. Again, you always want to make sure to put it in the lowest terms possible. In this case, we have -1/7 plus a -2/7. That's that keep on rolling. You keep all those addition rules in your head for integers. They were going to work for rationals now as well. You can think of it as -1 plus -2, and that's -3. Not going to be any different here. We're going to have a -3/7. As I said, keep in mind you need a common denominator. So don't be thinking 9. If you're thinking, oh, the denominator is going to be 9, I'll have to hurt you. All right, you got to go and you have to make a common denominator. So again, if you need some help on that, go back and review that, because you got to have that under your belt before you can handle with the positives and negatives. You have 4/6 plus a -1/6. Again, you have the fact of there are more on the positive side than on the negative side, so our answer is going to be positive. And again, the difference between a 4 and a 1 is 3. Remember, reduce. Got to keep that in your head. This is probably the hardest one situation when you have to get that common denominator, because you got to do all that first before you can actually kick into the positive and negative rules. Decimals, a lot of people are a little bit better on decimals because they can kick back into money. Something that we hopefully deal with every day. But in any case, you have a positive and a negative. So when you're going to add those of you going for the partial credit, you look to see what you have more of. And we have 4 versus a 3. So we have more on the negative side, even though 3 is a bigger number. But our final answer, again, you take the sign of the number with the larger absolute value. Here's what's a little weird, because, or weird for some people I should say, because we're adding, but yet I have to subtract to find the difference, because the signs differ. I have to find the difference. I can't like know what that is in my head. Here with rationals, you don't take anything for granted. You have to literally write it out and actually do that. You can notice when we had our integers, you could do a lot of stuff in your head. Fractions you can't necessarily do in your head. Decimals, actually much harder to do in your head. So you'll find yourself having a flashback to a lot of earlier knowledge, I'm sure. Now subtraction, we're going to kick back to the board that we just did. The subtraction, remember, is adding the opposite. We make two signs and then we can combine. So we have this 3/4, and we're going to try to take away a negative fraction here. I'm changing to addition, and then the negative now also becomes positive. We made 2 changes to keep things in balance. Again, we kick back from there, we kick back into our fraction knowledge. Common denominator, keep the denominator the same, and add up the numerator, and we can make that a 5/4, or for you mixed number people, 1 1/4. Decimals, same kind of situation. Again, make 2 changes. We're going to change this sign. Right? We got the -2 and 3 thousandths. We're going to subtract 1 42 hundredths. Change the subtraction to an addition. Change that sign of that number that follows. So again, we're going back to addition. Now a negative plus a negative. Let's sort of that keep on rolling. We got a negative with a negative. We're literally going to add those 2 numbers together. But that one wasn't maybe too bad to be able to add. Again, as we said, sometimes you have to write the actual computation down. When in doubt, write it out. And so you'd have here in this case a subtraction problem. First number stays put. We change it to addition. The -3 2/10 now changes to a +3 2/10. And you see that the signs differ, so I have to find the difference. Here's one that I wasn't going to try to do in my head. You can actually write it out. So you get a 2.5, as you like to say, 2 5/10, but that's going to be negative. Don't forget to go back and make sure to put the sign. Sometimes you get so happy you got an answer, you forget to go back and put the sign in. Multiplication. A little bit nicer. You can see that whether you're dealing with fractions or decimals, you still have to remember, hey, a positive times a negative or a negative times positive, as long as there's one sign there, you're going to have a negative. Negative times a negative, just like a positive times a positive, your final answer will be positive. So watch out on reviewing all those decimals and fraction knowledge. Again, make sure you have that under your belt before you try to merge it with the idea of having those negative rules. Division. Going to sound like the same old speech here. Again, negative divided by a negative is going to be a positive. Again, you got to make sure you have the mechanics of when I'm dealing with dividing a fraction. It's like multiplication with a twist, and then you can carry on through in the rest of that knowledge. Likewise, when you're dividing decimals, remember, hey, a negative divided by a positive, right away you know your answer is going to be negative, like in this case for this problem. But when you divide by a decimal, you have to review how first and foremost your divisor has to be a whole number. So you notice how we have to do some switching first of our decimal points, then we can set it and forget it and go about our division. So once we got that 8.5, we have to go back and double check. A negative divided by a positive is a negative number. And just as a review, once you finish this, remember, negative divided by negative, going to be a positive. Again, both worlds combine. And lastly, practice. Again, both things come together, both the fractions and the decimals, and now your knowledge with the positives and negatives. So just like anything, doing a sport, a foreign language, playing a musical instrument, practice. Good luck.